My name's Andy Weightman. I'm a lecturer in medical mechatronics within the School of Mechanical Aerospace and Civil Engineering. Okay, so the project's all about teaching our students about data acquisition, which enables them to engage with the world around them through sensing things and using actuators. And this enabled the students to take this away, and off their own bat they designed a system for delivering humanitarian aid through a quadcopter drone in disaster areas. The name of this project it's quite a long name which I can't quite remember. So it's something like embedding data acquisition to teach mechanical and aerospace engineering. Well, I guess in terms of the students, it's empowered them to kind of look at the challenges that are around us in society and to come up with solutions with those and kind of engage with it on a technical level. So this one, you know, the humanitarian need was in kind of disaster zones such as earthquakes and things. Getting aid to people can be quite difficult, but if you can take out the need for a pilot of a helicopter, for example, and you can let kind of lower skilled people pilot drones to deliver that aid in a safe and effective manner, then the students have kind of solved that challenge. It's at a pilot stage at the moment, but we do have a prototype device which is being kind of used at the moment and is kind of engaged with some of the competitions and stuff. So yeah, no doubt they'll take it forward this year. Yeah, so I guess the skills that we've embedded through this unit is enabled to take an existing system and add to it using a different data acquisition system. And with that data acquisition system, they can use new sensors, collect all that sensor information, and they've been able to do them kind of very, the technical aspects of it very quickly and effectively. Yeah, I mean, my role in terms of after I've taught them, they came to see me and said, we've got this idea, you know, can you help us implement it? So, you know, National Instance came along and they very kindly donated the technology, and then the school kind of purchased some sensors for them. But pretty much it was done as a student club, so they went away and engaged with it, and I just supported them in their efforts really. So the kind of real achievement is by our students. Yeah, so this is like, we have a robotics society, which is kind of split across the School of Electrical and Electronic Engineering and also the School of MACE, so Mechanical Aerospace and Civil Engineering. And the students just come together, we provide them with some equipment that they may want, and we help them to kind of engage with whatever activities they want. But this is through the Unmanned Aerial Vehicle Society, which again is split across multiple schools and the faculty. I think we try and embed it as much as we can within our teaching really, because it's important for us to have socially responsible graduates, and you can look at a number of the other schemes that are going on within the school to see how they're doing that. For example, the Big Engineering, where we do lots of widening participation and outreach. So we think we're kind of fostering a spirit of social responsibility within the school. Well, I actually know Josh, who went on to set up that business, so he was actually involved in the Robotics Society a couple of years ago. So yeah, I don't see any reason why they can't go on and achieve exactly the same thing that Josh has done. I think it's about an awareness of the world around them, which obviously social responsibility is a key thing, but being aware of these challenges, seeing these challenges. As engineers, we inherently are designed kind of and taught to solve problems. The great thing is to engage with the wider community to identify the right problems to solve rather than creating our own.